everyone. My name is Ayun Ghosh. I'm a technical lead in SRM Zilla, and today we're going to be covering the topic of introduction to blockchain. And along with it, we're going to be building a simple blockchain in JavaScript. So if you think that you have enough knowledge on blockchain and you don't need an introduction to it, then you can directly skip towards the implementation part. And for the people who need a basic introduction to what blockchain is, then stick along. We're going to first cover the basic introduction of blockchain, and then we're going to move on the implementation part. So without further ado, let's begin. So blockchain, as the name suggests, is a chain of blocks. So here, as we can see in the image, we have block one, block two, block three. They are connected with chains. Now, the best part about is that all the chains are interconnected. You can first of all think blockchain as a linked list. All right. So here's a linked list. Now, as you can see, the lists are linked with each other. That's the similarity between blockchain. So there's a hash of one blockchain. Like this first block, the green block has a hash. That's a hash code actually. The second block has an hash code as well as the third block. Now these three blocks contains the hash code of the previous block as well. So this makes all the three blocks interconnected. And what, like, why does it help? Why is it the MSP of blockchain? Because if you make any changes in a block, say you make any changes in one transaction of block three, then not only the hash value or the signature of the third block gets changed, the hash value or the signature of all the blocks, be it one, two, and every block gets changed as well. So even if you make a small change in any one transaction of any single block, the entire blockchain would be corrupted because the signature of the entire blockchain would be changed. Now, if this seems a little bit difficult to you if you are totally new to blockchain, I'm sure this would seem a little bit difficult for you to understand, but worry not. Everything, all your doubts and everything will be cleared once we go to the implementation part, and you'll see for yourself how all the three blocks are interconnected and how changing the value of one block gets results in a corruption of the signature of the entire blockchain. So, uh, in let's see what a blockchain is. Let's see the basic definition of blockchain. If you go to Google and you search blockchain, uh, I'm sorry about it. Yeah, blockchain definition. Let's see. It says a system in which a record of transactions made in Bitcoin or another cryptocurrency are maintained across several computers that are linked in a peer-to-peer network. Now, the definition of this blockchain is regarding the Bitcoin and cryptocurrency. And they are not in this part because the blockchain was introduced as the system to be used when cryptocurrency was introduced. So, blockchain was basically introduced by Satoshi Nakamoto, and you can search for the white papers of blockchain, and I encourage you to read the white papers for blockchain introduced by Satoshi Nakamoto, as it will give you an in-depth knowledge, and it's also a very fun topic to read. But here we are only talking about blockchain. We are not talking about cryptocurrency or Bitcoin. So let me tell you how blockchain was introduced. Basically, blockchain was introduced as a system to remove, to basically make everything decentralized, as we see here, peer to peer. So let me explain it to you better with an example. Let's say that you're in a bank in India, all right, um, and you have to forward or basically like give some money to someone who lives in Japan. Now, who you're going to trust to? Obviously, you're going to trust your bank. So you tell your bank, all right, I want to send this much amount of money uh, to a person in, let's say, US. All right. So what happens is that bank will first take the money from you in rupees because you're in India. Then it will search for the guy in US. It will convert your amount into dollars, and then it will give it to you, and subsequently it will also charge you for the service that the bank provides. Now, this is known as a centralized network. Here, all the transactions are managed by the bank, and the bank is the ruling party of everything. Now, let's say you have an account and some other person also has an account. Now, you know how sensitive this your account information, your PIN code, and everything is, and all of this, and it's the bank that you trust with your information. All right. So all of your information, the other guy's information, everything which you don't share with any other person is shared by the bank. So what blockchain does is basically, let's get back to our example. It is basically, it says, all right, let's say that you want to send the money. Okay, you'll put your money in blockchain, and then you'll just say that this much amount should be given to that much amount. This much amount should be given to that person who lives in Japan, and you put that transaction into the blockchain. Now everyone has a copy of the blockchain, and they cannot alter the transaction in the blockchain. Okay, so you are rest assured that whatever transaction you put in, no one can alter it or modify the data. So everyone there knows that you have actually made the transaction with that guy, and you don't need to rely on just single entity because there are multiple people backing up your claims. So even if that guy says, all right, I haven't received any amount from you or something like that, you can show them the blockchain that no, this transaction exists in the blockchain and it has been verified by all the people who are maintaining the blockchain. So you cannot make that claim. Now, um, let's see another very simple example. Um, I'm sure after this example, you'll get a very good idea of what blockchain is. Let's say that you and along with three of your friends are playing a game of cards. All right. Now, in this game, yeah, in this game, you're dealing with coins. All right. Now you don't have any coins with you. You've left all your wallet, all purse and everything at home. And right now you don't have any cash and everything, but you are playing the game of cards. And you have made a consensus within everyone that once the game is finished, we will give the amount of money that we lost or won to everyone. And this consensus is signed by everyone, and you all agree to it. Yes, whatever the transactions have been specified after the game has been finished, we will pay the transactions accordingly. So let's say Adam, Eve, Rahul, Priya, these four guys are playing a game of cards. Adam lost 10 coins to Eve. Rahul won 50 coins from Priya. Priya lost 10 coins to Eve, and Eve won 20 coins from Rahul. These are all the transactions that occurred in the entire game of cards. Okay, so there are people who lost coins, there are people who won coins, and what happens is basically when you win something or when you lose something, how do you note it down? You basically take a pen and a paper and note down the transactions. That is what you'll do. So we'll take all of this transactions and we'll note it down in a paper. Now, this can be referred, this piece of paper which contains all the transactions list by list can be referred to as a ledger. And what does a block contain? A block contains these ledgers which contains these transactions. So all of these blocks, this one, two, three, basically contains the transactions that has been made. It contains every transaction that is made is added on the block. Now every ledger isn't just added on a block, a new block is created and that is added to the blockchain. All right. Now, blockchain in itself is a very simple topic. The the difficulty comes in when we go towards the transaction and the consensus algorithms, which is here provided by cryptocurrency and Bitcoin. We are not focusing on Bitcoin or cryptocurrency. We are just focusing on blockchain. Okay. So let's start with the implementation, and I'm sure after we make a blockchain with ourselves, you'll get a much clearer view of what blockchain is. So let me first create a folder here. We'll be making the blockchain in JavaScript, so let's type in JS blockchain. All right, and basically I'll be using the terminal, but you can use any editor of your choice. So it's up to you. Now we'll be making the blockchain in JavaScript. So you need to have a basic understanding of what JavaScript is. Nevertheless, I'll be understanding you the entire code. So let's begin. Let's first go to our desktop and to the JS blockchain folder. All right. Now let's create the okay, we'll be creating three class. There'll be a block class, there'll be a blockchain class, and there will be an app class. You don't need to worry about what this is. We'll basically cover everything. So let's create our block.js class. Again, you can make this in any editor of your choice. It's not necessary for you to go in a terminal or something else. I chose a terminal. You can make it in like Sublime or anything else. So let's open block.js. Now, uh, so basically this name, what this class will do is it will make that block. Okay, the block is created in this class itself. So basically it contains the structure of what the block will be. And in order to code for blockchain using JavaScript, we need to have this library called crypto. So let's call it to our class. Okay, now we'll create a block class. Sorry about that. Let's create a constructor. Now the constructor will have a few parameters: the index, the timestamp, the data, and the previous hash. Now, what are these things? The index, timestamp, data, previous hash. As self-explanatory this name suggests. Let's see what these are. Index, all right. So index is basically this block number one, block number two, block number three. This is known as the index. Index represents the index of the block. Now, timestamp represents when the block was created. So whenever the block is created, a timestamp will donate the time and the date. No, the time and the date of the block created. The data contains the actual transaction that is present inside the block, and the previous hash, like this. The previous hash contains the hash of the block prior to the block. Okay. So, so previous hash is basically the hash of the n minus one block, where n is the current block. So let's begin. So in the constructor, we'll specify objects for each of the parameters. Equals to previous hash is dot timestamp equals to timestamp, and similarly for data equals to data. All right, now we'll also need a hash. Okay, the block will also contain the hash. Hash is basically the digital signature here. So this dot hash is equals to this dot calculate hash. You might be wondering what this calculate hash is. Well, this is the function with which we can create the hash for the specified block, and we are going to be implementing this calculate hash function. So let's implement it right away. Calculate hash. Um, let's create a string. Now this string will contain the following items. It will contain obviously the index. All right. It will also contain the previous hash, basically all the parameters of a block. So this dot previous hash, it will also contain, yep, the timestamp. And in order to be on the safe side, I'll be converting it to stringify. Basically, I'll be stringifying the data. So wait, let me first write this dot data. Okay, so we don't know what the data basically is. It can be a string, it can be a number, it can be anything. Basically, we can ask the user data in a number format or any other format. So in order to be on the safe side, we are going to be converting the data into string and then storing it into the string to hash, which contains all of this information combined. Now, once this string to hash is created along with all the information about the block, we are going to be encrypting it with the hash. So we'll use the function of the crypto class. As I said, that this module is very important when we are making blockchain related applications using JavaScript. So return crypto dot create hash. These are the functions of the crypto module. Okay, so we'll be using SHA-256 encryption. This encryption supports to the power 256 values of encrypted data of alphanumeric values. You'll see SHA-256 encryption when we will be when we'll be doing the working part of the blockchain. All right, so we'll update this, basically do these changes to our string to hash string that we've just created here now, and digest it to hex code. Okay, I believe that's it. Now let's export it to a module named as block so it can be used in our other classes as well. So I believe that's done. Let's save this and let's create another class known as the blockchain class. All right. Let's get inside it. All right. So this blockchain class will first of all call the previous block class that we just created. So let's call it first block equals to acquire block. All right. Let's create class known as blockchain. It will have its own constructor. Okay. So right now for so in a blockchain, to add another block to a previously existing block, a previously existing block actually needs to exist. So in every blockchain, there's a genesis block or the very first block that needs to be created. So we are using this constructor to create the very first block to which the other blocks will be added. So let's create it. New block. We'll be calling this block class, which we defined in the previous class. All right. Add in the parameters index. Obviously, since this is the first block, the index would be 0. Let's add the timestamp, new date dot new date. I'm sorry, new date dot to UTC string. Okay, the data, well, let's just type in the very first block, and since it's the very first block, the previous hash would be 0 since there's no block prior to this. So our first block is created, and every other and the next block will be added to this block, and then the other block will be added to the next block, and so on. This chain will grow. So this is basically the starting of a chain, and congratulations, you just created your very first block of your blockchain. Now there's still a long way to go, and it'll be fun. Let's go. Let's create a previous hash function. This function returns the hash of the previous block. So basically it will return the hash or the signature of the n minus 1th block, whereas the n is the current block that we are referring to. So let's return this dot chain, this dot chain dot length minus 1, and we'll obviously hash it dot hash. Now we are, as I told you earlier, we are able to use this type of function because we have called in the crypto module into our JavaScript classes. All right. Now let's create the add block function, and this, as the name suggests, will add a new block to the blockchain. So it'll take in the data from the user, and then it will basically define all the parameters that are required in the block in a block. So what are the parameters? They are the index, the timestamp, the previous hash, the data, and yeah, guess that's it. So let's define the timestamp. Obviously, the timestamp will automatically be sorry. Okay, yeah. The timestamp will automatically be created whenever the block is created. So new date dot to UTC string. So a timestamp is automatically added to the block whenever we add the block. So we don't need to define that whenever we like specify the block again. So everything is done for with this part here regarding the timestamp. Similarly, the index would basically be this this dot chain dot length. Now, obviously, whenever a block is added, it's added to the very last of the blockchain. So the length of that current blockchain will be the index of the latest block. So this is what this constant index will have. Now let's define the previous hash. Previous hash is basically this. We'll call this dot get previous hash. Previous hash. This is the same function that we have just created here, which returns the n minus 1th hash. Let's make a new block. Okay, so the new block will obviously call the block class, which we already defined earlier. So the same parameters: index, timestamp, data, and the previous hash. Previous hash. Hash. All right. So here, right. So right now we have basically defined the how to add a new block. So all the parameters that present in the block, the index is done for, like taken care of, then the timestamp is taken care of, the previous hash is taken care of, and the data is obviously the data that we've been providing it to the block. So we don't make any changes to the data. We want it as it is, and safe and like prevent others from customizing it. So, all right. Once the block is created, we need to verify that the block is valid or not before adding it to the blockchain. So let's define that function. If this dot is valid, if this dot is valid, new block, this is the block that we just created, new block, then this dot chain dot basically push it to the end of the blockchain, push the new block if it's verified. All right, now basically, so if the blockchain is valid, it will automatically push it to the block. If it is not valid, then we'll basically generate a simple error message that says the block is invalid, or any error message of your choice. I went with this one. So if you're thinking if this is valid is also a predefined function, then let me tell you it is not. We are going to define this is valid function. The is valid function will basically contain some certain cases or something, certain conditions which checks for the validity of the block. So let's create it to understand it better. Is valid r will pass the new block as a parameter for this function. Now the, let's define a current block. Current block would be this dot chain dot length -1. Okay, so if the new block is the block that is at the very end of the blockchain, then the current block is the block that is right before the new block. This basically the current block here, we've defined the current block as the previous block of the new block. So if the new block here is the nth block, then the current block is the n-1th block. And that is what we are accessing it using this dot chain dot length -1. Now, um, okay, once we have the new block, we have the current block, we can start with the validation conditions. Our first condition would be if current block dot index is not equal to, no, dot index +1 is not equal to new block dot index, okay, then return false. Okay, so what this does is basically if the current block's index +1 is not equal to new block dot index. So again, it is pretty self-explanatory, but let me explain it further. So if the current block's index +1 would obviously be the index of the block next to it, which is the new block, as we've already covered that the new block's previous block is the current block. So here we just checking that if current block's index +1, which should be equal to the new block's index, is equal or not. If it isn't equal, as if this condition states true, then it will return false and it will say that the block is invalid and the block will not be pushed into the blockchain. Now, this is our first condition. Let's check some other condition. Else if this is true, then else if new block dot previous hash is not equal to current block dot hash. Okay, then return false. So basically here, else if new block dot previous hash is not equal to current block dot hash. So if new block's previous hash, which is basically the signature of the block prior to the new block, So you know that we are referencing to the current block is not equal to current block's hash. So yeah, as it's pretty clear to you by now that we are basically checking if the block that is previous to that of new block has the same hash of the current block, which was we are already referencing to, then the block is valid, and if not, then it will return a false. Now we check for the index, we check for the previous hash. um, let's just create one more condition, else if for one more and final condition for the validation process. Else if new blocks hash is not equal to new blocks dot calculate hash, then return false. Okay, at this point of time, it's basically getting pretty redundant here. It's just that we are checking if the new blocks hash is similar to the new blocks calculate hash, that the function which we created. And so keep in mind that we don't specifically need to have all these three for the validation process. It's not mandatory for you to have this index checker as well as the previous hash checker as well as this hash checker. You can have just one, this index checker, or you can have any two functions, or you can have your own method for checking the validity of the block. This is just any three methods for which we can verify the block that we have created, and the verification process changes from blockchain to blockchain. All right, in our blockchain we can verify it using this. In other blockchains there can be other process of verification or something like that, and based on the blockchain or the security that you are going with, you can even have many more functions for checking or conditions for checking the validation of the block. So um, yeah, our is valid function is created. So if all of these conditions are true, then finally we'll return a true. So this will state that the block is valid and can be added to the blockchain. And once it's done, let's create another function, print j, that will basically print the blockchain. So it's just a very simple thing. We'll just console.log the entire chain, and all the details of the chain will be printed out for you. Now, as we did with the previous class, we'll export this as well to a module in order for it to be used in other classes. So we'll use blockchain, export it as a blockchain. It's because the class name is blockchain. So let's save it. Yes. And move on to our third and final class, the app.js. Nano app.js. I'm sorry, I went to some other folder. Yeah, let's exit this. Mm, Nano. Let's verify that this app.js is created or not. Yeah, the app.js is created. And as you can see, it's empty. App.js is empty. Let's go to app.js. Okay, we are inside app.js file. Now, first of all, let's call our blockchain class that we already created. Blockchain equals to require blockchain. So you might as well notice that we don't need to call each and every class that we already created. We are not calling the class block that we created earlier, and we are just calling this blockchain class because the block class was already called in the blockchain class, and the crypto module was already called in the block module. So we don't need to call everything again and again if it's already been called into the subclass that we are calling, the sub module that we are calling. All right. So now we have in the block and the blockchain classes, we have defined the structures of the blocks, as well as uh, how to add a new block as well as the first block, and as along with it the verification process as well. So all we need to do in this final class is we need to pass on the data. It will already go to the blockchain class. The blocks, the first block is already created in the blockchain class, and using the add block function, this new block along with the data passed is added to the blockchain, and the verification process is done and everything, and once it's done, it's pushed to the blockchain, and everything is carried forward. So let's create my chain equals to new blockchain. This is the class that we created earlier. This contains the structure of the chain. Now my chain dot add block. Let's say mm, what were the transactions? Adam lost 10 coins to Eve. So sender is Adam, okay. Receiver is Eve, and well, they were dealing with our own coins, the Kezila coins. So let's say that the amount is 10 Kezila coins. All right. So we'll add another entry to the ledger. My chain dot add block. Well, let's just, and in here we'll just type in this. Okay, the data can be in any format. It can be like sender, receiver, amount, or just a word, or in any other format as well. So we are unaware of what the data might be. We are just adding it to the blockchain. So here we are calling the add block class, in which the data is passed on, the other parameters are set automatically, and then the chain is added. As a matter of fact, let me show you how it's done. Let me save it right here, and let me go back to the blockchain class. Yeah. So as you remember, we called the add block data and we sent in the data, just the data. All right. The data was that Rahul or Adam lost some Kezila coins to someone, like that. Now, the timestamp is already defined. The timestamp will be the date at which the block was created. The index is basically this .chain.length. The previous hash is called using this function. Everything is pretty has already been explained, so I'm not going into detail again. And the new block is created with all the parameters in itself. The validation process is then um, called, and once the block is verified, it's automatically pushed into the blockchain. Where have I written that? Yeah, this chain push here. So let's go back to our app.js. Yep. So once all these chains are added, let me call in the print chain class, or the print chain function that we created earlier. Print chain. I'm sorry, I'm writing the function. It's print chain. Okay, let's save this as well. All right.